Toronto, where one of the most complex tunnel boring projects in North America is underway.
Look at the size of this thing. A huge tunnel, 3 times the length of the Golden Gate Bridge. It's a long way down there. Is being built beneath one of the largest bodies of fresh water in the world.
What's the problem? The cable's jumping.
Oh, you can see the swing there.
On the move.
But what happens when a $15 million, 100-ton tunnel boring machine breaks down? It means an epic battle to get it fixed.
First time we started the TBM and shattered one of the gears.
As everything that can go wrong does.
What's going on with the crane?
Even his major problems threaten to shut this operation down.
We fire up the cooling system and it's fucking leaking all over the place.
Come along for the ride on Impossible Repairs.
Yeah, baby!
My name is Mike Davidson. Coming around! This is so great. I've worked aboard and inside some of the most incredible machines on Earth.
This thing is pretty badass.
Here we go. Now I'm going back in. It is tight in here. I just love it. Digging into the guts and bolts of these machines to discover how the hard hat heroes who keep things running,
Power's on. Nice and easy.
make it all happen. You've got a problem here. This is Impossible Repairs.
Hey, nobody wants to talk about it, but every time you run a tap, wash your car, or flush the toilet, that water has to go somewhere.
And nearly 800 kilometers north of New York, in Canada's largest city, Toronto, waste and sewage from millions of residents goes through the Ashbridges Bay Treatment Plant, a facility in need of a major upgrade.
Toronto is a big city with an aging wastewater system that's barely keeping up with its needs.
When Toronto's wastewater system was built, the city had only 380,000 residents. But more than 100 years later, it's closing in on 3 million. That's a lot of flushing toilets.
The system manages sewage, water from washing machines, showers, anything coming down the drain, including stormwater.
It's a problem that communities all over North America are dealing with today. Aging infrastructure that can't keep up with the expanding population. The solution? A new multi-million-dollar wastewater system, 80 meters down, to give the water someplace to go.
Basically, it's one hell of a drain pipe.
Whoa, that's intimidating. So we can get down there and we can take a look at the assembly. All right, make sure the safety harness is good.
I'm being craned into the hole just like a hunk of metal. It's a long way down there, 80 meters. This hole is just the beginning of the operation. Down inside, crews are starting to work on a massive tunnel that will be dug underneath Lake Ontario and transport disinfected wastewater 3.5 kilometers out into the middle of the lake. For this job, they need some serious equipment.
Welcome to the big show, the tunnel boring machine.
The tunnel boring machine, it's a very complex system with hydraulics, electrics, very extensive.
This TBM is a highly sophisticated piece of equipment, and it has to be, because the tunnel is being built under Lake Ontario, one of the largest freshwater lakes on the planet. 76 meters below the water, this machine will drill 3.5 kilometers across, creating a tunnel with a diameter that's more than 2.5 stories high. This $15 million beast just came off a job in Mexico, so the first challenge was getting it here.
Every project is a battle. This was no different. It's over 1,000 tons of equipment to get the machine lowered down the over 80 meters down into the shaft.
Right now, the TBM is in thousands of pieces 80 meters below the ground.
Yeah, watch your head.
To keep this multi-million-dollar project on schedule, the massive and multifaceted TBM must be totally assembled in a matter of weeks.
There's a lot of pressure from the top. I mean, we have a schedule to follow.
The tunnel will take years to complete, but with millions on the line, Kevin's team needs to get drilling within a month.
As long as the welding is past 50%, so they have to get so much done so that we can release the temporary support.
Even the smallest of delays would cost hundreds of thousands of dollars.
Things need to be perfect. We need to do them right.
Once the tunnel is complete, disinfected wastewater will flow from the treatment facility, down the shaft, and along the tunnel by gravity. The pressure of this flow pushes the water up into a series of 50 pipes to disperse into the lake. The system is called an outfall.
This is one of those really unique projects.
we're building a shaft that's a football field into the ground. The tunnel itself is going to go out underneath the lake about 3 times the length of the Golden Gate Bridge.
It will connect with the Ashbridges Bay Treatment Plant, the start of the system, where the dirty water gets clean. From our construction site, I'm driving 450 meters up the road to where the waste comes in, so I can discover just how big the problem is.
Look at this, the size of this structure. This space is incredible. Where are we right now?
One of the 2 pumping stations for the Ashbridges Bay, where basically raw sewage is collected into this big wet well, and these 1,500 horsepower pump this raw sewage into the facility for further treatment.
These pumps are a massive size. What sort of volume is going through here?
Basically, the total pumping capacity of these 5 pumps is 1,353 million liters a day.
Wow.
In a day.
Okay.
This facility pumps the equivalent of 42,600 beer kegs of sewage on an average day.
The sewage starts here. This wet well is about 8 stories high, full of sewage. It fills up and goes to these pumps. There's 5 of them at this pumping station right now, handling the regular flow of sewage in the city. During a wet weather event, can barely keep up. There's definitely a smell in this area. This is where all the grit ends up.
That's right. There are huge bar screens that will screen out material, anything that goes down the toilet and your kitchen sink and through the storm drains.
All right, any work that needs done here?
Absolutely, man. We would like you to rake that pile.
The glamorous side of my job is never ending.
Wow, look at this. This is the biggest rake I've ever seen in my life.
Yeah.
Hey, I'll take a big rake any day.
It's pretty long, allows you a far reach.
At least it lets me keep my distance. 4.7 million tons of this gunk is pulled out of the wastewater every day.
That's right, now you'll get a whiff of it.
Fortunately, I've got a strong stomach.
Oh, look at that. You can see the steam coming off of it. It's warm.
Oh, yeah.
It's hot.
It's warm and hot, steamy poop.
Yeah, it's a steamer. It's a
Yeah.
steaming poop. There we go.
There we go.
Oh, I see some coming out.
Yeah,
Oh, fresh screening poop right here.
it's a poop rain. Michael, you're pretty good at it. You want a job in here?
Yeah, exactly.
There's nothing like being right in the thick of it to understand exactly how much waste they're dealing with here.
Got a workout and got a nose full too.
That's right.
After my shift at the treatment plant, I'm going 450 meters back up the road and 80 meters down into the hole to check in on the TBM.
No, yeah, continue that.
This gigantic tube-shaped drill with an engine that turns a 2.5-story high cutting base is still in the assembly phase, which means welding, wrenching, and getting all its pieces in place. Entering into the tunnel boring machine. How do you navigate through this?
Kind of go with it one step at a time.
It's not designed for easy access. It's tight, it's wet, it's slippery. If you don't watch your ass, you're going down. This is a main access point.
This will be daily maintenance inspections and stuff like that.
Okay,
Other than that,
so guys crawl in here
exactly.
and check the cutters, make sure everything's working properly.
Check for wear, make sure everything's where it's supposed to be.
It's a big machine. Does it have a name?
It does. It's called the Raptor.
That's because this machine rips through the earth like the velociraptor disemboweled its prey. The Raptor.
Yeah.
I like it. Man, that's badass. But what's behind that ferocity?
Let's see. Let's check it out.
It's the Raptor's powerful disc cutters. What do you see?
Well, normally we look for mechanical wear and stuff like that. This is good. This is what you want to see.
At the heart of the tunnel boring machine's massive drilling ability are the cutter blades that bite through the earth. Each of the 49 cutters is 90 kilograms of hardened steel, and they're about the size of a soccer ball, with a large dinner plate-shaped blade. The cutters are arranged across the 8-meter wide front surface of the TBM, known as the cutter head, where they work together. So when this monster starts spinning, it tears through the earth like butter. We've been inside the tunnel boring machine and inside the cutter head. Now it's time to swing around and see the front of it. Here it is. Oh, look at that.
Well, that's definitely the business end of the tunnel boring machine right there. It's a menacing piece of hardware.
But its days are numbered. On this job, they can't easily pull the TBM out at the end when it's done drilling through 3.5 kilometers of rock and shale, because the TBM won't fit back through the tunnel. Instead, the crew will encase it in concrete and lay the Raptor to rest underneath Lake Ontario. But first, they have to get it there.
Whoa! Whoa! This is full speed on the crane. There we are, daylight. And that was 15 seconds?
Yeah.
That's tough.
The scale of this job is truly astounding, so I'm going to check it out. 3.5 kilometers away in the middle of Lake Ontario, crews are getting ready for another phase of tunnel construction.
At the heart of this tunnel boring operation are massive pipes.
This is where the Marine Division has been installing the outfall. 50 pipes or risers that will eventually connect to the main tunnel after it's built.
So the risers make the connection between the top of the tunnel to the bottom of the lake bed.
Clean water will flow through them and into the lake. But the brutal Canadian winter is rolling in soon, and these workers need to prepare for it.
That's where we're heading.
Crews are racing against the clock to lock this barge down before winter hits, and this lake becomes a frozen wasteland.
To set the outfall pipes in place, they have to pour concrete into 23,500 kilogram steel casings or guide pipes. This concrete fills the space between where the pipes will eventually connect with the tunnel. Once the concrete sets, they remove the guide pipes. When temperatures dip to minus 26 Celsius or colder, it becomes a dangerous job to complete. So they need to get it done before things freeze up.
We're just trying to catch every window of opportunity that we can to get the concrete poured on the last two for the season and get the structure out of the way.
Keep going. Bring them up.
They poured the concrete, and now it's time to pull the containment pipes out of their footings and the water. Easier said than done. We're pulling the boat away. They're about to lift the steel out. This pipe's going up, about 23,500 kilograms. They'll use a crane connected to the barge to pull the last one out.
There's so much pressure on it. It's down in the lake bed when you're pulling it, so you have to really clear back for safety. Cables go flying, pipe goes flying. It's a really dangerous part of the operation.
They're gonna pull this pipe and then they'll spin it all the way around and lay it down over on the 141 barge.
23,500 kilograms, 25 meters of pipe, up out of the lake. Here we go. Or maybe not.
What's going on with the crane?
The crane's cables are getting tangled.
They've got a cable twisted up in the top of the boom.
We kind of flick it.
And the pipe won't budge.
You know the fucker?
It could be stuck in the bottom of Lake Ontario.
Get it untangled before they do damage.
Back on the barge, a 23,500 kilogram containment pipe is stuck in the lake bed.
What's going on, Willard?
The mud has formed a suction cup around the heavy pipe.
They're pulling up so much force on the crane to lift the weight of the pipe and get it to break loose from the suction of the mud in the lake.
But they have to be cautious, because if they pull too hard, it could damage the crane, the pipe, and also the concrete connection to the lake bed beneath.
Hopefully they can get it fixed.
They check the cables and the connection,
Just had to find the sweet spot.
and test them against the strength of the pipe. The crew gives it one more forceful pull. Problem solved. It's unstuck.
Yeah, so the pipe's actually broke free now and broke the suction from the mud. So now he can ease it down, swing it over here, and lay it down on the barge.
All right, they got it done. They figured out the crane, lifted this out of the lake bed. Check it out. It's awesome. Right on. Got the pipe out.
There's no damage to the pipe or the concrete connector for the tunnel, so they can safely seal things up until the spring.
Barge is locking down. The pipe's out. Job's done. We're out of here.
After a day on the barge, we're headed 3.5 kilometers back to the tunnel site,
Over there.
where tunnel boring machine manager Kevin Collins is moving 8 house-sized parts of the TBM into the hole.
Yeah.
These pieces are called gantries. They house the hydraulics and electrics that power the TBM. The gantry is at the back of the tunnel boring machine. Each of these sections weighs about 23,000 kilograms. They'll start lowering them down and in through the shaft to the back of the tunnel boring machine and finish building it. Much like how an earthworm's body is separated into sections that have different functions, each gantry has a different role in powering and supporting the TBM.
He's okay there, Curtis.
This gantry's main function is to install the concrete that lines the tunnel as the TBM enters it.
Right now we have the TBM down in the tunnel,
Yeah.
and then we have to place each gantry in the proper location to continue.
It's the basement. All 8 of the gantries have to be craned down this 80-meter deep shaft.
You have to bring it back over, the cable jumping. Mike, copy.
Whoa, you can see the swing there. Is it swinging a bit?
What's the problem?
The cable's jumping.
The problem comes from the cable. It's packed loosely, so the cable is slipping. Do you want to tighten it up?
I'm gonna have to try and pull something down heavy or something just to set the thing.
Since the cables have become so loose, the crew needs to pull them tight again. The best way to do it is to hook up a heavy weight at the end of the cable and let gravity tighten up the spool.
We need to send the cables down here and take this excavator out.
This 8,000 kilogram
Yeah, you're good.
PC-78 excavator is the heavyweight solution.
We're gonna hook the loader up. That'll take that slack out of the cable, and they'll try again.
A loose cable could snap under the weight of the gantry, sending 25 tons of metal plummeting towards us.
Okay, 10-4, line down right there, Mike.
Curtis is lining up the loader so the crane can pick that up, fix this slack problem. We'll give it another go on the gantry. Working fast on this. They want to get this gantry in today. There's some weather coming in over the lake. You can see it. It's rain and with it wind. When that happens, you won't be able to do a lift with the gantry. Curtis has the loader ready to lift.
So it looks like there's some rain coming, some dark clouds, so we're gonna get this down unhooked so that we have to boom the crane down if there's any lightning. Keep coming down.
A huge chunk of metal on a crane could be a magnet for lightning, so they have to work fast.
Okay, Mike, buddy, you're clear to take it all the way.
Okay, there's weight on the chains here. It's going up.
You don't see that every day. A loader going up an 80-meter shaft.
Does the trick every time, though. Look up
Yeah.
a loader, fix your cables.
That's it.
That's why it's down here.
The weight of the excavator is straightening the cables. So they drop it at the top, and now we can bring down the gantry.
We're getting it done before that weather might come in.
Yeah, we gotta get it off the crane. Keep coming down, buddy. Everything's looking good.
Here comes the gantry. That just looks wild. They eliminate any swing. They don't want that crashing into the side of the shaft.
A collision like that would be like a semi-truck smashing into a building.
It's like a house coming at you.
Hold him there. Swing him left a bit. I'm good right there. Down. Line down nice and easy. Keep coming down. You're good there? Yeah. Good, good. Okay, you're landed.
Nice
Thank
work,
you.
Curtis.
Thank you, buddy.
The house-sized gantries line up on the 65-millimeter rails just before that storm got serious.
Yeah, our chain.
Now that they're done with the heavy lifting, they need to finesse the gantry into place. The last piece of this puzzle is connecting Gantry 1 and Gantry 2. It's about 30 centimeters apart, and they're gonna close the gap with chains hooked up to these 2 beams. They're gonna winch it in place. When they get it together, a pin locks it in place. The puzzle's complete. For a machine this massive, we need an industrial-sized pin. This one weighs in at 33 kilograms.
It has to go across about that much.
So it's a really tight fit, these 2 big pieces. So to get them all perfectly aligned every inch, it's tough.
Okay, it's going. There we go.
When all else fails, give it the boot.
I just need a hammer or something, Cam. I'll get it.
This calls for some heavy artillery.
Yeah, baby. Hit it. Yep. Finito.
It's just the beginning. Gantry 2 of 8. A lot of work still to do.
All right, out of the shaft, down there with the tunnel boring machine. Come back up. It's nighttime.
The work never stops on this project. Overnight, the crew start building a railway so they can move the TBM farther into the shaft. And by the time I'm back in the morning, They've nearly completed their work on the first 6-meter section.
This is what the TBM will move ahead on right here.
The TBM must move 1.5 meters into the tunnel to make space for the next gantry.
We're going to build the next section. We move ahead 1.5 more meters.
When you're moving something that weighs as much as a train, you need some seriously sturdy rails.
Have you ever had a problem with this where you got to the point where it did tip over?
I don't want to say regularly, but it does happen, derailing the gantries, and it's not easy to put it back online.
And that's just one of the risks in assembling and moving this 700-ton giant.
Time to go.
Time to move it?
Yeah. Just bouncing.
So this is it. This is what moves it ahead.
This is it right here, this lever.
This is master control right now for this push.
On the move.
When it's not chewing through hard rock, the tunnel boring machine can't move on its own. So they use heavy-duty hydraulic pistons called thrust cylinders to push the TBM into the tunnel.
Oh, I think they made me stop here. There's a lot going on over there.
There are more gantries to install, but now they're ready to test the engines. Hydraulics push the TBM forward, but 442 horsepower engines power the cutter head. Time to turn them on.
The rails are in place. It's go time. We're gonna fire up the tunnel boring machine.
This is the first time they'll get this $15 million machine up and running.
We got it up right now.
80 meters below the surface of the Earth, workers are scrambling.
You got the radio!
And that can only mean trouble.
What's the problem with this?
There was a mechanical failure inside the tunnel boring machine.
I'm not sure what's going on.
Some sort of issue, maybe?
I'll go check it out.
You got the radio!
First time we started, the TBM rotated a couple feet and shattered one of the gears on the main drive.
So Kevin is going inside one of the motors to see what the damage is.
Yep, shrapnel.
Oh yeah. The tunnel boring machine has 7 interconnected drive motors that all move in the same direction to spin the cutter head. On the end of each motor is a gear, and they all work together to make the cutter head spin. So even if only one gear becomes overwhelmed, it can break apart inside the TBM, shatter, and bring the other gears and the entire operation to a halt. That's what happened here.
So Kevin spotted the piece of the gear, the tooth that blew apart. It's wedged down in this area, so it's just trying to force it out. They have to account for the entire gear that blew apart. There's pieces of it everywhere, and this is a good chunk that he can reach. So, Kevin, you see it?
Yeah.
It's just stuck?
Yeah.
Oh, there it is. Oh, yeah.
Located just behind the cutter head, these motors drive the TBM through the rock. Without working motors, the TBM can't move.
Kevin's inside the inspection hatch. He's looking for any other damage that may have happened.
They're missing like 6 teeth, it looks like.
We're going fishing for gears.
But fishing here means pulling things out of a 68-centimeter wide hole.
We have to get all of the pieces out of the shattered gear because this can cause potential damage to the other gears as well. We don't get every piece out.
This mechanical failure has put 38 jobs on standby and sent this multi-million-dollar project back more than a month.
Yeah, it's a big repair.
This is an absolute disaster. It will involve removing each of the 7 motors, their gears, and every piece of shrapnel, cleaning and replacing each gear, and reassembling the cutter head.
Major problem. Sometimes we see a little bit of fatigue, cracking, spalling on the sides of these teeth. Something's majorly incorrect. I think the reason the gear shattered is because the material wasn't strong enough.
Now the TBM is dead until they can fix the problem.
Yeah, I can't glue that back together.
Kevin returns topside to share his findings with the rest of the crew.
So this is a gear off the main drive motor number 6, and this one appears to have manufacturer defect in it. It's the pinions. We have to remove them all.
These parts are built to withstand 2,000 kilonewtons of torque, the equivalent pulling power of 55 drag racers. but this one shattered under less than half of that.
This doesn't happen very often, I'm assuming.
Never. Nobody's seen this before. So this doesn't happen.
Because all 7 gears are from the same manufacturing batch, the crew is gonna have to replace them all. It's the worst case scenario.
Huge scale engineering, tunneling project. It can grind to a halt with one small piece, one problem.
Kevin's crew could wait months for the replacement parts.
I feel like we're going backwards here.
Yeah.
While the TBM crew assesses the damage, we're moving to another part of Toronto's water system, where more aging infrastructure is being repaired. From our TBM site, I'm going 7.5 kilometers west and 30 meters underground to the Cross Harbor Water Main, one of Toronto's freshwater tunnels. While the new tunnel is the end of the line for wastewater, this water main is where clean water starts its journey into people's homes.
This is fantastic. We're in this water main tunnel, downtown Toronto.
It was built in brick in 1906.
There's horse and buggies in the city at that point. I mean, they had to blast this, take all the dirt out with buckets and donkeys. Right now, it's going through extensive repairs with this new steel and concrete liner.
These repairs will cost almost $14 million.
It was starting to collapse at points.
Well, the TBM will drill the back end of Toronto's water system. This tunnel is the start. That's why it's imperative it's repaired.
The noise that you can hear is the pump, right? Because if we turn that pump off, this will fill up with water.
But we have a ways to go to get out, so...
But if there was a collapse or something like that, then you'd be running.
You'd be...
30 meters below the lake is not a great place for a tunnel collapse. Or a leak.
This isn't a concern right here, water jetting out of the side of the brick.
We'd rather it didn't happen, that's for sure, yeah. But because the obvert here is brick, if we actually plug that, it's likely that it's just gonna come out someplace else. So at least we know it's relieving the pressure here. We're just gonna let that go. This is what we call a pisser.
Yes, pisser is the official term.
It's Italian fountain.
Is this like clean lake water? You can drink it?
Yeah, you can taste it, sure.
All right, I'm gonna take a drink.
Sure, try it.
All right, I'll try it. It's not bad. It is a little salty. There's something in there.
Yeah, yeah.
Well, the leak isn't a problem. The lining of the tunnel is a structural concern and needs to be repaired. So they've installed a new inside layer in the tunnel and are patching up and sealing the seams.
It's a big job. How many seams do you guys have? It's about 130?
Yeah, it's over 100, 135, I think it is.
That stretch out over 800 meters. If you've ever patched concrete or drywall at your house, you'll know the joys of this kind of work. So I'm lending a hand.
I think I need some more. I can put a little bit in there.
Each 12-meter section takes about 4 hours to seal, and by the looks of things...
These guys keep working?
I think I'm actually slowing the process down. Time for me to let them work.
Thank you. I'll let you guys get back at it. Thanks.
4 weeks later, back at the TBM site, they're still waiting for new gears.
Still a line down there, bud?
Yep.
While the crew waits, they're working on the conveyor belt system.
TBM is down. There's a lot of other equipment to work on, so we'll get busy with that until the new parts come.
On working tunnel boring machines, the continuous conveyor system transfers chewed up rock from the TBM up and out of the tunnel. But with no material to move right now, they can work the kinks out of the conveyor system before the TBM starts spinning.
First time we fire it up.
Anytime they start something up on this project right now, kind of keep their fingers crossed. There's been a lot of things to work out here, getting this system fired up.
Right now, the crew are testing the tracking on the conveyor to make sure rocks coming through won't fall out the sides.
So this here, on either side, we can either move forward or backwards. That turns the roller left or right.
The conveyor belt has seams where each piece joins together, and every connection is a potential weak spot.
Yeah, it should be real cool. It's coming at you now. Go on.
The goal today is to test the system, so when the TBM starts drilling, everything is ready to go.
Go up front.
But within seconds, there's trouble. this crew just can't seem to catch a break.
They stopped the conveyor, not because the test was over, because there's an issue with it. There's a problem.
Conveyor system breaks down. We can't get the chewed up rock out of the tunnel, so we're stopped.
Is this place right here?
Yeah.
Those metal brackets?
Exactly, yeah. Connects two pieces of belt together.
Some of the brackets came apart during this test, and now the entire belt is out of alignment.
Okay, power's off.
This should be over here, basically.
The guys need to loosen the belt so they can reposition it. And because Kevin's still waiting on TBM parts, he's letting this greenhorn in on the action.
Down, boss. So we're gonna loosen this, give it some slack, right?
We're gonna get the cable across.
Once you get that across, lock it in place and run it again. How far is this going? Is yours done already? Just a bit ahead of you.
I can take over if you want, buddy.
That's okay.
A few turns of a wrench in the right direction, and it's fixed.
All right, did it.
Thanks, buddy.
You're welcome. Job well done.
Belt's realigned, everything's running now, so hopefully that's it for this system and it continues to run good.
As they wait for the TBM's new gears,
a lot of assembly and testing at the moment right now.
Senior project engineer and construction manager Kevin Wahr is on site to supervise the installation of concrete liners in the tunnel. They're installing 6 concrete segments to form a ring.
This tunnel is going to be supported by these concrete structures.
These pieces of concrete are installed using one of the TBM's gantries.
These concrete structures hold the tunnel from falling in place.
By the time they're done, over 2,200 of these 7 by 1.5 meter liners will be installed in the tunnel and support the weight of the lake above it. Acting as the foundation for the TBM to push against into the rock. That's why the first ring needs to be installed now. And let's get down there and take a look.
Game on.
These concrete segments line the tunnel like puzzle pieces. If each piece of your puzzle weighed 5 tons.
You gotta add it slowly, incrementally, one at a time. They put them in a very specific order. It's very intricately assembled.
It's called the key segment. It's the last one that goes in, and so it has the most complexities in terms of getting stuck in the tightest position.
The segments are bolted into the tunnel wall, but to get these giant pieces lifted into place, they use vacuum suction.
It's the same thing as your household vacuum if you inadvertently hit it against a piece of paper. In this case, we're using this extra large vacuum to pick up a 5-ton piece.
Well, the other 5 segments have a little wiggle room because the last one completes the circle. It's the tightest bit of all.
They're bringing this one in. They're about an inch away.
Away from the kid.
Our side's a little high. They just have to bring it down, push it in. All right, here we go. It's going in.
It seems like an easy fit. But looks can be deceiving.
It was going in, now they're pulling back. Something's up.
If this segment isn't aligned properly and falls, it could kill. The tunnel boring crew is installing a concrete lining at the front of the tunnel. But the final 5-ton piece of this segment isn't fitting. And it could fall if it's not secure.
Smallest adjustments. These could come smashing together. Could ruin one of these pieces, make it a real bad day.
Hey, look it on the line up there.
Hey, can I plug it up there, Ben? Looks good.
The TBM can't start cutting rock until all 6 concrete segments are in place, forming a ring that holds back the weight above.
I need more, yeah. One more touch like that? Yeah.
So the crew is pulling out the troublesome piece and trying again.
They're on the final piece of the ring. This is the most critical part.
That's right. The last segment locks the ring together and allows us to safely continue on with our tunneling. Until this keystone is installed, there's a chance that this lining may fall in.
You're good up here.
They got it!
What is this?
Meanwhile, topside, a very important package arrives.
The gears are here.
Nice.
The tunnel boring machine just been here collecting dust. We want to get that thing going so we can start cutting rock.
After weeks of waiting, the crew can now fix the TBM and start drilling.
Okay, Kevin, what do we have here?
But what we have right here is the gearbox. This is one of the gears made out of the raw material. So this will go to the scrapyard.
The old steel gear shattered under a pulling power equivalent to 55 drag racers. But the new ones are built from stronger steel that can withstand the force of the TBM.
So what has to happen here? The new part comes in and...
Yeah, so we're gonna spin the motor and line it back up with a hole right here. And then assemble the proper pinion onto the shaft, bolt it on, and then push it in.
That's no easy task when each motor weighs nearly 5 tons.
Cool, so this one will go next then?
Yeah, this one is next. Slap this on, bolt it up, torque it, put it in.
Here it is.
Okay.
The crew have to install a new gear on each of the 7 motors. But when a single gear weighs as much as a man, it's anything but easy.
There's 7 motors around the diameter of the cutter head. This is for one motor right here. The old gear has been pulled off, and that's the front. It's waiting for the new part, that new gear to come in, and it'll fit on right here.
Go for it.
Chief TBM engineer Alfredo Garrido heads up the crew for placing the gears.
That one, ready? No. Okay.
Just trying to work the gear onto the motor right now.
Hammering on the gear takes brute force and precision in a very tight spot.
If you're working hard in the machine, you don't need to go to the gym. The gym is the TBM.
Each 100-kilogram piece has to be aligned exactly where the TBM won't work.
Does it feel like it's going in?
Yeah, it's going in.
Oh yeah, I can see it moving there.
Yeah. Just a cut, yeah.
Finally, the new gear is in place.
Okay, we have assembled the pinion, the retainer. So now we need to put Loctite in the ball,
They have the pinion gear on, bolted in. They're just gonna torque those bolts. We're gonna push this motor in. That's it. Yeah, nice job there, Alfredo. Yeah. The guys are getting close. They're right at the doorstep to finishing this repair, getting the new gears back on, and then firing up this TBM. Right there, you can feel the energy's back here.
No, you cannot be confused because you're right the way it is.
A month behind schedule, they've called in the night shift to finish putting the TBM back together.
Let's go in a little bit, boys. So I gotta look at that pilot inside there.
Leading the team is mechanical expert Brian Benema.
This is the night shift right now. This is my window to be down here, following these guys all day and into the night.
Brian's near impossible task is to push this massive motor back into place.
It's about 5 tons right above me, and they've lined it up, ready to go into the cutter head. You can see right here. Hopefully we get it. It could be a long night though.
Okay, hold up.
All right, what's about to happen here?
We're going to reinstall this drive. It's a matter of going carefully and slowly, and watch your fingers. Tommy, this has got to come up. Yeah. Yeah, just a hair. Okay, keep her there.
Here we go. Motor going in. They get this done, fire up this TBM. Brian, what's the most challenging part of this right here?
It's a lot of weight and difficult to line up.
If you can imagine having to lift the weight of a fully loaded pickup truck in the air and put it in a 68-centimeter spot, then you'll understand how hard this is.
What's preventing it from going in right now?
It needs to be lined up absolutely perfectly.
And how tight are the tolerances in there?
10,000ths of an inch. This is beyond paper thin.
That's 10 times thinner than a human hair.
Hold on. Yeah, that's it. We're getting into fine tuning here, so.
The guys almost have this behemoth aligned.
Yeah, well, you got an even gap where you're at there, Brent? Okay.
The motor won't go back in until it's perfectly in position. And they're having a tough time making it fit.
Brian, is it right there?
It's close. It's very close. Can't be any closer without being in. Gotta hold still. We're there. 5 ton versus 5 men. The 5 tons lost. It's official.
What a fight.
This TBM's looking good. We are on the edge of going mining.
What a team. What a crack team.
The crew worked the rest of the night, replacing the other motors.
4 o'clock, I need to go up.
So 12 hours later, Kevin's team can start testing them to see if the TBM can finally get to work.
Main drive motors are installed with the new pinions. Cutter head rotation's been checked. Everything's okay.
This crew is so close to cutting rock. But just as they're ready to roll, there's another issue.
That's so we fire up the cooling system and it's fucking leaking all over the place.
Just like in your car, the cooling system is vital to the TBM. Without a working one, the motors won't function.
Larry, how come you didn't fix this leak before?
We'll get this.
This time we get lucky. It's only a loose bolt. We tighten that up. Now we're good to go. We're gonna start. I need to have eyes everywhere.
I'm standing at the face of the cutter head. It's about to go. Look at this monster. Here we go. This is the moment.
Just let me know when you start advancing.
Get ready to move the machine forward.
Right now we're voting between 5 millimeter and 10 millimeter per minute.
Copy that?
This is wild. The cutter head's spinning. We're gonna hit the face of this rock.
Yeah, this is definitely a big one as far as nothing else goes on.
And we're cutting!
Finally! We broke 100 millimeters, 4 inches. Show me some rock. There's some shale for you. Souvenir. First piece of rock right here.
Alfredo! Yeah, man, all right. It looks great. I can't believe it. It looks so awesome. Kevin! Yeah! Kevin's still game face on right now. He's not celebrating yet. Don't leave me hanging.
Now that the tunnel boring machine is up and running, it's going to drill 3.5 kilometers of earth under Lake Ontario, moving the equivalent of 70 Olympic-sized swimming pools of rock and shale to make way for the outfall.
Seeing the conveyor belts with the rock, with the sound of the TBM going, how do you feel?
I'm so proud of our team. It's exciting. It's happening. It's been a long time coming, and here we are.
This multi-million-dollar project is finally back on track.
It has been a battle, but we are ready to tunnel under Lake Ontario.
When you finally reach that point, when it starts making material come out the belt, you kind of think like you did something, right? It is exciting.
Feels good. Feels so good. I think back at everything I've seen and experienced with these guys, the grit they've shown, thinking back to the barge operations, the start of assembly with Gantry #1, the problems they faced, the challenges they overcame, fixing this thing when it just kept throwing them curveballs. They figured out a way around it, got it done, and they're cutting, they're drilling. Amazing.